For this problem, you've got to draw this free body diagram to be able to do the vector sum. So let's start off with the free body diagram. Here's the slope. Try that again. Here's the slope. And if this dot here represents Leo sliding down the slope, then there's some frictional force, Fk, that's holding him back. And there's a component of gravity in this direction, which we saw was Fg sine 35 degrees. It comes from the fact that that angle there is 35 degrees. So those two forces are parallel to the slope, and then there are forces perpendicular to the slope. Here is the other component of gravity, Fg cos 35, and here is the normal force from the surface pushing up against Leo, holding him up. You've got to use a dot. You've got to be able to draw forces parallel and perpendicular to the slope. And notice the friction is always in the opposite direction to the motion. Finally, make sure that the kinetic friction, this force here, is the shortest one of the three arrows to show that it is a smaller force. Now 4.2 says that we must calculate the frictional force, Fk. So to do that, let's have a look at what's happening to the forces parallel to the slope. Effectively, the sum of the forces, the gravitational component plus the frictional component, is going to equal the F net. And F net in particular is equal to the mass times the acceleration as it goes down the slope. So if we can solve enough things here, then we can actually get Fk. Let's think about that. We can work out the gravitational Fg because we know the mass, and we know the acceleration, and we know the mass, so we can also work out F net. So therefore, Fk is going to be equal to F net minus Fg sine 35. F net is mass times acceleration, and that is 85 times 0.4, and Fg is going to be the mass times gravitational acceleration, 9.8, times sine of 35. And when you punch all of that into your calculator, you get 444 newton. You get minus, why does my minus keep disappearing? 444. Now what is this? This is a force, so therefore it's in newtons. And the fact that it's negative, what does that mean? I.e., it is up the slope. Why is up the slope negative? Because originally when we put the acceleration in here, this acceleration here was positive. And acceleration is down the slope, and so therefore down is positive.